This is our last addition strategy, and there's subtraction ones come to 2. But for the addition strategies, our last one is to break apart one of the numbers to make a 10 with the other number. Because what we have left now is 7 and 8. We want the children to think about whenever they add 7 to a number, they can take 3 from the other number to make a 10. Because remember, they've automatized and make a 10s. They know 3 and 7 make a 10, and 8 and 2 make a 10. So they can think about that. They can apply that strategy of knowing the make a 10s to this strategy of make a 10 and have some left over. Then it becomes 10 plus a single digit number, which is actually really easier for the children. So if we're adding 7 plus 5, they can think about taking 3 from that 5, make a 10 with a 7. I have 2 left over, 10 and 2 make a 12. So it sounds like a lot of thinking, but it actually can happen within a relatively few seconds, and it lends itself beautifully to math down the road. We're trying to make whole numbers, let's say with decimals, or whole things with fractions, and even algebra in high school. So this strategy is super, super important. So this strategy is including adding 7 or 8 to another number, and the strategy is at making a 10 with the 7 or the 8. So let's say, for example, that I was adding 7 plus 4. So I'll move 4 more over here. I actually want to think about, well, if I could figure out how many more make a 10, I can make it easier for my brain. So I could move these 3 over here and take those 3 from there, and I have 1 left over. So I've made a 10 and I've got 1 more. So 7 plus 4 ended up being an 11, a 10 and a 1. Let's say that I was going to be doing an 8. So I have 8 plus, let's say 5. Well, what I could do is think about filling my 10. It takes 2 more from an 8 to make a 10. So if I take these 2 to make my full 10 and take those 2 away from my 5, I'm left with 3 more, and 10 and 3 makes 13. We can also be acting this out using our 10 frames and any kind of counter or manipulative, or even pictures with markers on it. So let's say I wanted to do 8 plus 5. Again, I'm just going to show it to you for a second, that I have my 5 on the separate 10 frame, but these 2 can move up to fill that 10. So now rather than thinking about it as an 8 plus a 5, I can think about it as a 10 and a 3. It's a lot easier for my brain. I took 2 from the 5 to make my 10. If I had, let's say, 7, so I'm going to do 7 plus 5. So I have my 5 down here. Again, I need 3 to fill that 10. So I've got a 10 and a 2, which makes my 12. With our Cuisenaire rods, also a really wonderful way of being able to see it. Let's say that I'm going to be adding 8 plus 6. Well, it's going to take 2 more to make that 10, and I'm left with 4 more out of my 6. So my 8 plus 6, I can think of it as being 10 plus 4, which is the 14. If I were going to do it with a 7, let's say, so 7 plus 4, when I think about making my 10, it takes 3 more than 7 to make a 10, and what I'm left with is just 1 more in that 4. So I can think about that 7 plus 4 as being a 10 plus a 1, which is an 11 and much easier for my brain. And this strategy here gets progressed all the way through the kids' math education. It can be used for decimals, we can make our wholes. Even measurement, we can think about 8 inches plus 5 inches. If I take 4 inches from the 5 inches to make a foot, it's a foot and an inch. There are not any procedures or rules for the children to follow. They're going to forget the steps to. They can think of it as a conceptual understanding to know what's happening when they're making a whole. So this particular strategy of making a 10 is huge.